You're listening to the N2K Space Network.
Around every entry point and every clever attacker, Vectra sees the attacks others can't. How? Vectra has AI on it. Vectra's AI attack signal intelligence tells security teams where to focus, what matters. It wades through thousands of individual threat events so you don't have to. Attackers infiltrating your network? Vectra has AI on it. Attackers compromising your identities? Vectra has AI on it. Vectra AI, the integrated signal powering your XDR. Visit vectra.ai/showme to learn more. That's vectra.ai/showme to learn more.
It's another week in the space world, and one in which we're expecting things to settle down a little after everyone's travels to the IAC last week. But do things ever settle down in space? Can we rest on our laurels when innovation is taking place every day and we continue to send more objects into Earth's orbit? Certainly it seems we've had another wake-up call this weekend with more space junk scattering in GEO.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger, roll.
Today is October 21st, 2024. I'm Maria Varmazis, and this is T-minus. Intelsat loses the IS-33E satellite in GEO. SpaceX launches 20 Eutelsat Group OneWeb satellites. Space Systems Command awards SpaceX $733 million in task orders. And today's guest is Steve Jones, STEM educator and principal investigator at Magnitude.io. Steve shares about how he has combined his passion for space and astronomy with his classroom activities and how he got his students involved in ISS experiments. It is super cool work, so definitely stick around for the second part of the show. Happy Monday, everybody. I hope you're all rested up after a busy week of space out at the IAC. So let's dive into today's Intel briefing, shall we? We're starting off with some news that developed over the weekend. Intelsat shared that their IS-33E satellite in geostationary orbit had experienced a severe outage. The satellite experienced an anomaly on October 19th, resulting in a loss of power and a loss of service to customers across Europe, Africa, and parts of Asia. Intelsat announced that they were working closely with Boeing, the satellite manufacturer, to address the situation. They shared that based on the information available at the time, they believed it unlikely that the satellite would be recoverable. Intelsat 33E was launched in August 2016, but didn't enter service until January 2017 due to a problem with its primary thruster. The satellite was designed with a lifespan of 15 years, but that was reduced by 3.5 years after another propulsion problem occurred during its orbit tests. So we are doing the math here. We are only 8 years into its planned 12.5-year lifespan. And it seems that the satellite is absolutely unrecoverable. After it was shared on social media experts, and yes, we're looking at you, Jonathan McDowell, that the vehicle had actually broken up. And that was later confirmed by the news that the U.S. Space Force was tracking at least 20 pieces of debris where Intelsat 33E once was. It's not yet known what caused the disassembly, but we do hope that someone takes responsibility for removing their trash from GEO. In the meantime, Intelsat is working with their customers to mitigate service interruptions. And speaking of satellite communications, SpaceX's Falcon 9 launched and deployed 20 satellites into low Earth orbit as part of the Eutelsat Group's OneWeb constellation over the weekend. The satellites separated successfully from the vehicle and were dispensed in 10 batches over a period of 20 minutes, with signal acquisition confirmed on all 20 spacecraft. Eutelsat Group says the satellites, which were all built by Airbus US Space and Defense, will strengthen the company's network services, improving overall performance for customers. And speaking of SpaceX, the U.S. Space Force's Space Systems Command awarded National Security Space Launch Phase 3 Lane 1 launch service task orders, totaling over $733 million, to SpaceX. These are the first 2 task orders for Phase 3 Lane 1 issued under an indefinite delivery, indefinite quantity contract awarded in June 2024. They include 1 task order for 7 Space Development Agency launches and 1 for a National Reconnaissance Office mission, which is due to launch in the 4th quarter of 2025. The innovation arm of the U.S. Space Force, SpaceWorks, has selected Anello Photonics for a SBIR Phase 1 contract to develop a resonator laser gyroscope. Dr. Mario Paniccia, CEO of Anello Photonics, shared in the press release that by leveraging our vast integrated photonics expertise and AI-based solutions, we aim to further support Space Force's mission around providing capabilities to the joint forces operating in GPS-challenged environments. A large meeting of Artemis Accords signatories, including the United States, gathered at the International Astronautical Congress in Milan last week, and the meeting was co-chaired by NASA, the Canadian Space Agency, and the Italian Space Agency, with 42 of the 45 total signatories participating. And according to the press release, leaders from each nation reflected on how the group can contribute to and advance existing multilateral forums, further technical discussions to inform policy deliberations, and promote and encourage the participation of emerging space nations, including the adoption of the Artemis Accords by additional countries. They agreed on recommendations on non-interference, interoperability, release of scientific data, long-term sustainability guidelines, and registration to advance implementing the Artemis Accords. Also on the sidelines of last week's IAC meeting, Avio, the Italian company that manufactures the Vega C rocket, says the vehicle will launch again in December. Avio CEO Giulia Ranzo told Reuters that Vega C will be back on December 3rd. Not only have we made the required changes, but we recently carried out 2 expensive ground tests to make sure that it works. The Vega rockets were grounded in 2022 after the Vega C failed in its second launch attempt. The December launch will be part of the European Union's Copernicus Earth Observation Satellite program. The United Nations Office for Outer Space Affairs has released a study on gender equality in the space sector. UNOSA says this is the largest study of its kind, gathering insights from 53 space agencies and public space organizations globally to assess gender representation and policy in the space sector. The key findings include that 1, women make up 30% of public sector space organizations, but only hold 19% of board roles and 21% of leadership positions. Number 2, the report found that women are particularly underrepresented in technical, astronaut, and policy roles, but there's an overrepresentation of women in education, outreach, HR, and admin roles. And number 3, and out of all of the world regions, African states are closest to gender parity in space. So, go Africa. UNOSA says that it is apparent that more needs to be done to mainstream gender across the space sector, and the organization is taking steps to correct it. They have introduced the Gender Mainstreaming Toolkit for the space sector, which addresses challenges and provides practical solutions for member states to promote gender equality. And we have to note, we've seen many try to correct representation in this industry, but few address issues with retention. So it'll be interesting to track the impact of this toolkit as it rolls out. As a female-run space podcast, we are all very supportive of gender equality here at T- in the growing international space industry. And that concludes our briefing for today. You will find links to further reading on all of the stories we've mentioned in our show notes. Hey T- crew, if you would like daily updates from us directly in your LinkedIn feed, be sure to follow the official N2K T- page over on LinkedIn. And if you're more interested in the lighter side of what we do here, don't forget that we are at T- Daily on Instagram. And that's where we post videos and pictures from events, excursions, and even some behind-the-scenes treats. Links are in the show notes for you as always, and hope you'll join us on social media.
Quick question. Do your end users always, and I mean always without exception, work on company-owned devices and IT-approved apps? I didn't think so. So my next question is, how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question: Extended Access Management. 1Password Extended Access Management helps you secure every sign-in for every app on every device, because it solves the problems traditional IAM and MDM can't touch. And it's now available to companies with Okta and Microsoft Entra, and in beta for Google Workspace customers. Check it out at onepassword.com/cyberwire. That's onepassword.com/cyberwire.
Today's guest is Steve Jones, and he's a STEM educator at Fulton County Schools Innovation Academy in Alpharetta, Georgia, and a principal investigator at Magnitude.io. I asked Steve how he got involved in space education.
I am an astronomy and scientific research teacher, and I've been a lifelong lover of space, NASA, astronomy, all of that. And I now get the opportunity to make my career what I do that I love. Just last year in 2023, I was named the Tony So Excellence in Educator Award recipient from the ISS National Lab. The big thing that I've done is working with a company called Magnitude.io. And they have a program which I found out about at the Space Exploration Educator Conference in Houston. And I found out about their program, ExoLab, where they launch experiments to the International Space Station, and then they allow classrooms around the world to get involved with those experiments. And so ExoLab 6, their sixth launch, I talked to my principal about it when I found out about it, and he said, that sounds great. Let's go ahead and do it. So he funded my classroom doing that at the middle school, and it was great. And then after that first launch, I got to meet the owners of the company and their director of education, and met them at Seek the following year. And they said, well, look, we've got another one going up. Are you joining us for that one as well? I said, well, I haven't talked to my principal, but I'll think about it. And so I talked to my principal. He said, yeah, let's do it. And then through my relationship with them, they asked me to come on and join their team of principal investigators. By doing that, we helped to develop the experiment that was going to be flown to the station. And there were several of us that are teachers. And so what we did is we developed the curriculum that was pushed out through the platform to teachers to use with the experiments as they go.
Can you tell me about the experiments that you've been a PI on? I mean, that's really cool.
So the experiments we're looking at, we're going to have to feed people when we start getting settlements on the moon and settlements on Mars, et cetera. And, processed and packaged food only lasts so long, the nutritional value. There's also a big psychological benefit for astronauts to actually grow food. And so what we would like to do is be able to use what's there. Think about, as humans have moved along the globe and explored different regions and settled different regions, you basically live off the land and live off what's there. Well, we know what's on the moon. We know what's on Mars. There's not a lot there. So if we could use the regolith that's there and then use that to grow plants in, we will be doing a lot better. The problem is you can't send fertilizer up into space because it's kind of explosive, and a big bomb on top of another bomb is not a good idea. So the big thing that we've discovered is trying to figure out how do you get nitrogen for the plants to grow. And the only two ways that nitrogen fixation happen, or that you get nitrogen into nitrates into a way that a plant can use it, is through lightning strikes. I don't believe we're going to be generating any lightning or developing any lightning. That's kind of dangerous as well. and it's through symbiosis, nitrogen fixation through different types of bacteria and organisms. And one of those big ones is rhizobium bacteria. And so what we're doing, if you look at legumes, clover, for instance, you go to your
Clover is a
backyard.
legume? Sorry, I didn't know that.
Yes, clover is a legume.
I thought you were going to say lentils or something. Clover. Okay. Yeah. All right.
I'm glad you mentioned lentils because that was my pet project that I wanted to have done in Exolab 8, but didn't happen.
Okay.
But that was fine.
That's cool. I love lentils. So that's like lentils. All right. Clover though. Clover. Let's go.
Yeah. So clover. So anybody, I mean, and any students, you can go to your backyard, you can dig up some clover and look at the roots, knock the dirt off of it, and you'll see little bumps, little nodules along the roots. That's basically a symbiotic relationship between the rhizobium bacteria. And so they basically form a colony on the roots. So that bump, that nodule is like an inflammation type of thing. But what those bacteria do is they absorb the nitrogen from the soil, from the air, and turn that into nitrates. And so they're basically feeding the plant. So it's a symbiotic relationship. They're feeding on the plant, but they're also giving stuff to the plant. And that's how you end up getting nitrates into the soil that plants can use. So we've talked about using clover as like a cover crop. So you take some rhizobium bacteria, which has flown in space many, many times. It's a known entity. And you could then start a crop of clover, get it to grow, and then till that into the regolith. And now you start creating soil because there's no soil up there. It's just because you have to have decayed plant matter. And so that's what we're talking about, doing a cover crop of that, and then you can start growing other plants in that. And now you've got it. So basically what our question was is how does the microgravity environment affect nodulation? And so we've been trying a couple of different plants, different types of growing media. We've learned a lot about what not to do.
I was going to say, I'm sure y'all were looking at The Martian at some point and going,
Absolutely.
okay. Yeah. I mean, this whole time I'm going, okay. Thoughts?
Yeah, absolutely. Well, one thing, and it's funny, I always tell my students because I did a study of The Martian with my 8th graders when I was teaching them in that STEM class. And we did the growing potato. I've got some Martian regolith. You can get some simulated regolith through, I think, the Mars Garden online. I think pretty some, and there's a couple other places. But basically, it's the stuff that JPL uses to test all of their equipment before they send them up there. So you can get chemically accurate regolith. And then I went to Lowe's and bought a bag of black cow manure. So it's just cow manure. It's been heated to kill any kind of thing that might be in there. And we use that. And so I have them mix that along with the regolith, and then we grew potatoes in it. So the cool thing with this experiment is we fly one experiment. Space Tango is the company who actually builds the device that goes onto station for us. And that goes up to the station. And then all of the students receive a 2U size, 2-unit size lab. And this analog lab has different, you can set the light settings on it, but it has sensors on it to detect carbon dioxide, humidity, temperature, and the amount of light. And then it also has a camera on it, so once an hour it snaps a picture of the plant. This is uploaded to a website run by Magnitude. And so students in the classroom are able to see, basically the students become the ground control system for the experiment because we've grown plants on Earth for years. We know how to grow plants on Earth. That's fine. They basically become the control group, and then they have live access to the data coming from station. So they get all the same type of data that they're getting in their classroom. They get the same thing from station, along with pictures of the plants growing. And so the idea is the more eyeballs you have looking at this data, the better chance somebody's going to notice something that maybe somebody else hadn't. What I like about it is it gives students an opportunity to conduct legitimate science. I always ask my classes, how many of you have done a science experiment before? And all their hands go up, and I say, no, you haven't. What you've done is a demonstration. Your teacher gave you a set of instructions. They gave you the materials, said, follow these directions, and then write what happens. I said, you baked a cake, basically is what happened. You baked a cake.
You knew what the outcome was going to be.
You knew what the outcome was going to be.
Mm-hmm.
Your teacher knew. Everybody knew. That's just a demonstration. An experiment, we have no idea. And I said, and people are actually going to use your data that you're collecting. So you're actually being involved in authentic research. So that's pretty good.
That is such a cool, the cool factor of that, it's in space. So yeah, you sprinkle space on anything, it's always cooler.
Exactly.
It's the fairy dust. But it is legitimately, that is, who knows what the outcome's going to be there. Obviously, I'm sure they, as part of the process, have their hypotheses. But it is a really, so what was the outcome? Do we know? What was the determination from that?
Well, we don't really know quite yet. There have been,
I love that
like
answer.
I said, we learned a lot of ways,
Yeah.
some different engineering things we've had to overcome on flights. And actually what we're doing now is we have partnered with the Berkeley lab, and they're going to be doing a lot of our genomics with it. Once we get things back, they're actually going to be using their machines to check the RNA of it. And we're partnering with the Gilroy lab and the NASA Gene Lab up in Wisconsin, and Dr.
this is
Gilroy.
High schoolers and middle schoolers do. This is legitimate.
Elementary schoolers. People all around the world. We've got schools in Germany, Romania, South Africa. Yeah.
That is. I'm
It's
jealous.
cool. It's really cool.
That is so cool. This is not, as you said, it's not a demo. It's not baking soda and vinegar. This is really, this is legit science happening. Wow.
We've got an experiment launching October 30th, assuming the launch doesn't get pushed off again on the next commercial resupply ship.
Yeah.
We were supposed to launch back in March, if that gives you an idea how long we've been.
Oh, my. Okay. My goodness.
Space is hard, as you know.
Yeah. Oh, yes.
But once that comes back, we're encouraging students to come up with their own experiments. Okay, you've seen how this lab works. What's another way we could use that? So I believe Magnitude's looking at open sourcing to allow students and high school students, et cetera, to come up with their own types of experiments. How would you use this device with these sensors? What is a way that we could change what we're doing? So
I love that. I'm a big fan of open source.
Yeah.
That's so great. That just makes my nerd heart happy because I'm a big open source fan.
One of the other things that we're hoping with this, because people always ask me, okay, we're doing all this stuff in space. What about the problems we've got here on Earth? Well, yeah, we look at a lot of the UN food scarcity strategies, and basically what we learn, what we can do in a harsh environment like the moon and Mars, we could do that here on Earth.
Of course. Yeah.
That technology could then be used here. So that's what we're looking for, that whole spinoff.
We'll be right back.
The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
Welcome back. We love it when science gets things a little bit wrong. That's the whole point of it, right? Have a hypothesis and then investigate the subject further? Well, take the discovery of the first brown dwarf, Gliese 229b. It was found nearly 30 years ago by Caltech astronomers, 19 light years from Earth. It's practically next door. Brown dwarfs are subjects that are too large to be planets, but too small to sustain nuclear fusion like stars. As the first brown dwarf to be discovered, it formed the basis for assumptions about others that then followed. But wait, we're getting to the part where they got it wrong. The discovery wasn't all that it seemed 3 decades ago. New research has found that Gliese is not an individual brown dwarf as first thought, but it's actually a pair of these failed stars orbiting each other closely. This discovery helps explain why Gliese 229b was dimmer than expected and offers new insights into how such objects form and evolve. And the findings were made using advanced telescope technology in Chile. These two brown dwarfs are gravitationally locked to each other in what's called a binary system, an arrangement that's commonly observed among stars. So the brown dwarf that 3 decades ago was named Gliese 229b is now recognized as Gliese 229ba with a mass 38 times greater than Jupiter, and Gliese 229b with a mass 34 times greater than Jupiter. And I gotta say, we think dwarf is a little misleading here, don't you think? That's it for T-Minus for October 21st, 2024, brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing space industry. If you like the show, please share a rating and review in your podcast app. Also, please fill out the survey in the show notes or send an email to space@n2k.com. We're privileged that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K makes it easy for companies to optimize your biggest investment, your people. We make you smarter about your teams while making your teams smarter. Learn how at n2k.com. This episode was produced by Alice Carruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazes. Thanks for listening. We'll see you tomorrow.